Team, it's Mr. Z, and today we're going to continue to look at how to write equations for forms of quadratics. It's going to be standard form, factored form, or vertex form. And we're going to kind of figure out which situation suits the problem. Let's dive in. So I have to write a quadratic function that is concave up. So what that means is essentially it's going to be, looks like this. Since it's concave up, I know that the vertex is going to be a minimum. The next part it's given me is that it is compressed vertically. Since it's compressed, that means it's getting smaller. So it's going to be multiplied by some sort of fraction, and it contains the zeros. Now, zeros, this word right here tells me that this is going to be in factored form. So I'm going to go ahead and set it up. It is f of x is equal to concave up, so it is going to be a positive number. I'm going to compress it vertically, so I'm going to make it smaller. I'm going to compress it to half the size, and then now it's going to be the zeros. Now remember, the form is always x minus. So when I plug in 6 and negative 2, I have my formula. Concave up, compress vertically with a transformation, and a 0 of negative 6 and negative 2. Now, all I would do is simply clean this guy up and rewrite the x minus minus negative 2 into regular form. Well, it will be positive. I can also omit the positive sign in the front. And voila, I have a quadratic formula with the zeros. I just do a quick check. Is 6 minus 6 0? Yes. Is negative 2 plus 2 0? Absolutely. All right, battle ready. Next quadratic. It is concave down. It has a vertical stretch, and it also has a maximum at negative 1, 5. Now, maximum. It is concave down. So the vertex is going to be this maximum point right here. And I get the coordinates. Since they tell me where the maximum is, this is going to be vertex form. So I'm going to go ahead and set it up. It is always going to be f of x is equal to the number. It's concave down, so it has to be a negative. I need to stretch it. I need to make it bigger. I'm going to stretch it by 2. And then the form is always x minus h plus k. H is negative 1. K is negative 5. I take the time to rewrite this to be the quadratic f of x equals negative 2 times x plus 1 squared minus 5. I forgot the squared in vertex form. That is a key component. Okay, the only thing I got to do is check, oh, it's g of x. So usually I'm such in a habit of writing f of x, I'm going to go ahead and put g. So this has just been a quick example on how to write some quadratic functions. These are all going to be typically the same. Number 9, notice, concave down. A is going to be negative. I also have been told that a y-intercept is 0, 2. This right here is an indication that it should be in standard form. And my c value is 2. So I'm going to write h of x is equal to a concave down, so it's going to be a negative number. Then I have my x squared plus my bx plus my c is 2. And I can go ahead and replace b with any value that I want since they didn't specify, so I'll make it 3. Okay, this final guy, it tells me that it is concave up. It has a vertical stretch. And then this new part is an axis of symmetry. Now, the axis of symmetry, you have to remember, since it's concave up, it is going to have a minimum. And the axis of symmetry is considering the vertex. It's talking about the x value is 3 for the vertex form. So, vertex information, I'm going to use vertex form. So it's going to be f of x is going to be equal to, actually k of x. K of x is concave up, so it's going to be a positive value. It is a vertical stretch, so it's getting bigger. I'm going to stretch it by 2, and it's going to be x minus 3 plus k. Now, they didn't specify the k part, so I'm going to insert my own number, and I'm going to go ahead and say 5. Okay, hopefully this has been some help in writing equations. This is essentially the proof that you know your bread and butter between these forms. Do you know the key information, and do you know which ones to select? That's it for now. Ciao.